Did it go? All right, good. All right, so with the elimination method, there are a few conditions that have got to be met. One of them is this. The two equations have to be in standard form. So look at this. Are they in standard form?
Yes.
We all remember how to identify that, right?
Both variables being on one side.
Right. Yeah, it's on the wall too, right? But yeah, the both variables on the same side. Exactly. Second thing is this, is that you have to have the like variables, the terms rather, stacked on top of each other. So, sometime, now I'll give you a hint because y'all be taking the ACT later this year. Sometimes what they'll do is they'll do like the X and the Y and then the Y and the X. Or they might say like, X minus 7 minus Y. They'll mix it up on you, just try to see if you're paying attention. So make sure, one, they're in standard form. Two, they're stacked on top. Third thing that has to be in place is something kind of like this right here. Like the leading coefficients have to be the same number. Maybe different sign, but the same number at the very least. Make sense? So that if we have those conditions met, we can eliminate the x's. Or if it happens to be the y's, kind of like you see on number 2, we can eliminate those and we can go find the x value and then plug that back in and find the y. So this method can be a little bit quicker, and I think you'll appreciate it. So here's what we have to do. Put a line under it, put a little set of parentheses off to the left. I bet a few minutes into this, you'll probably start thinking back to Algebra 1 and going, this looks vaguely familiar. Maybe. So you're either going to put an adding sign or a subtraction sign. The question is which one. And you base it on the thingy that you're trying to eliminate. So the idea is to make x and x go down to 0 when they pass through the parentheses. So this would be an easy one, right? 1x plus 1x, is that 0? No, that's 2, right? 1x minus 1x. 0, right? So I know that I need to put a subtraction sign in there. It's all about trying to get it to go to 0. So that goes to 0, and every term goes through that sign. This is where people are going to screw up with the signs. You got to do the 7. It hit you, didn't it? Does this look familiar?
No.
Oh, you said, oh. All right, so minus -1. You see how I'm writing it? 7 minus -1. What is that?
That's basically adding, so that put it up to 8.
There you go. 17 minus -7. So 17 minus -7. 24. Yep.
Is that easy?
Well, no, we got to finish it.
Oh, okay, I was going to say.
But yeah, so 8. Take the 8, divide both sides. What do you get? 3. So remember, the whole idea is to find the ordered pair, right? I know what the y is now. There you go. So which one do you want to use?
The top.
Okay. So we'll use the top one. So we got x plus 7 times 3 equals 17. So that's 21. What, 4? -4, sorry.
-4.
My brain's shutting down. You're done.
Would it work the same if you plug it into x minus y?
Mm-hmm. Yeah. So the x minus y. So the 3, that'd been x minus 3 equals -7. So when you add the 3, you still get the -4. Yeah. So it'll work in either one.
No matter which one you plug into.
Not at all. Because that's the point at which these two lines are converging. So that's the point at which they're both equal. Mhm. You like this better? This certainly, that doesn't take near as much board as that other one where it took all this. So I agree. So let's do this other one together. Which variables am I eliminating? The y, because remember, three standard form, lined up on top of each other, and they have the same number, right? Different sign, but close enough. Close enough for government work, right? So we got to decide plus or minus. So we base it on the thing we're trying to eliminate. So if I say 2 plus negative 2, does that give me 0? Yeah, so I looked up and got it right the first time, right? Now just to play devil's advocate here a little. What if I said 2, what if it's minus negative 2? Positive 4. So it wouldn't have been, my point is it wouldn't have been 0, right? So everything goes through it.
Oh.
Just like that.
That confuses me at first because, like on the part that it confused me more,
I'm listening to you. Go ahead.
is like on the first one that you showed us, it said that like you counted away, and it was going to hit negative because it went back 0. Because that's what I got from it. Like it went back. Like if it goes back, it's negative. If it goes forward, it's positive.
Are you thinking about the number of them?
No, I'm not thinking about the number lines because when they were counting, he goes like for number 1, he was like 7, 1, 2, and 3. Then later.
7 minus the negative 1.
Yes.
Like that.
Yeah, and I'm so confused. I don't know how to like find the sign for it. Like,
That still rattles you. Okay. Okay. All right. So to help with that, let me brush over that again real quick. All right. So the whole idea is I'm trying to make this right here go away. So I'm using the rules that I know about signs, right?
Yeah.
So if I said, so that I was trying to decide plus or minus. I'm gonna do the one that won't work, so you know what it looks like when it does, right? So if you said 2 minus negative 2, that would be 4, wouldn't it?
Yes.
So that obviously that's not getting me to 0. But if I go back and I say, okay, the positive, which is what I do have right there, I'm saying 2 plus a negative 2, which is really 2 minus 2.
Okay, so that would be 0 and that would be negative.
Right, that would be, so you don't see the y there.
Yeah.
Yeah.
Okay, I got it. It's like I was just confused how that worked. Like,
Does that help a little bit?
yeah, it did.
All right, so I assume, did y'all go ahead and find the y? Y'all already did that? What'd y'all get? Negative 1. So 24. Subtract 24. Negative 2. 2y. Y is negative 1. You get it? Don't judge my 1. Now I can give you a summary to how, if you can keep it straight in your head, how you can tell. Y'all listen to me. You might write this on your paper. This is pretty good. If you're trying to eliminate the variables you're trying to eliminate, if they happen to be the same sign, like both positive or both negative, kind of like what was going on right here, you subtract, and that'll get you down to 0. That's good stuff. I'd write that. So of the things that you're trying to eliminate, if the signs are the same, like both of them are positive or both of them are negative, you subtract. This messes with our minds a little bit, but it still holds because we're still the rules of signs being applied. If the signs are different, I'm going to add them to get it to go. Remember context. We're going down to 0. That's the point. Okay, so if the signs are the same, subtract to go to 0. If the signs are different, add to get it down to 0. Okay, so I'm going to go out of order just a little bit for this reason. I think 3 is just a little too obvious how to handle it. But so what I'm going to do is I'm going to pick one that's better to use a universal method that I'm going to show you, and you can go back and work on them. Look at number 4. So what I'm going to show you is how, see, none of those, so it's a standard form. They're stacked on top of each other, but there's nothing that's the same. So my third condition's not met yet. So I've got to force one of them to be the same. So, yeah. So I didn't hear you say it again.
What did you do 6 and 3?
6 and 3? So you want to eliminate the y's? Yeah. Okay. So first thing is you make a determination which one do you want to eliminate, because you got a little bit of freedom of choice here. So yeah, we'll go with what you said. Very good. That's very good. So I'm going to take the bottom equation, the whole thing, and I'm going to multiply by 6. Since I'm eliminating the y's, I'm going to use the coefficients of the things I'm trying to eliminate. The top one, I'm going to multiply by 3.
Could you not just multiply that bottom one times with everything in it by 2?
Yes, you could also do that. Yes, because that would give you 4x, 6y, and then the 26. Yes, absolutely. What I'm showing right here is a more universal. Yeah, because sometimes like this one, for instance, we're looking at one of them, it wouldn't work, right? So that this method here will work here. Does that make sense?
Yes.
All right, so we go through. Oh, and I'll tell you, this is where most people, aside from the signs, this is where they mess up. They don't distribute all the way. So like you're multiplying every term by that 6, and multiplying every term by that 3 on the top one.
So it's kind of like distribution property.
Well, it's exactly what it is. Yes. Yeah, you're distributing it to all. You're right. Oh, 159? That sound right? 159? That sounds good. Thing 78? Yeah? Yeah, 7. All right, now does it look a little bit familiar?
Yes, it does.
Now you apply the method that we were doing before to finish it. So see if you can make heads or tails of it.
Yeah, for the tails, I'm always wrong. I always pick tails. You had it, right?
I don't know, do you?
You know,
No, you subtract
Do you?
because it would be negative 18 minus negative 18, and those two negatives would make the positive.
That's right. Very good. That's right. Yep.
I was thinking
Yep.
it the other
That's why I had y'all write down that little thing earlier. I hope you wrote it down anyway. But that's why.
Keep looking at that thing because it's cool.
Yes. He's like,
It's like, good morning, Mr. Best.
oh, could you imagine coming in here like that?
Whew.
Because it cancel each other out.
81.
How would you do this now?
If it's positive, if it's positive, wouldn't that just be 18 plus 18?
Whoa.
Because y'all said that it would be positive.
No. We said right here, we're going to subtract.
So it end up with
So it would be
negative
Oh, put that in
plus
parentheses.
18. And that's going to cancel out to 0. And that's what you're trying to do.
So 21 minus 12. Okay, so you're going to
Damn, I
add
need to send it.
subtract, right?
Start following me again. Come on, boy. Come on.
You got my face on there. Am I going to be on the video?
Probably.
So here, like
All
21.
right, 20, so you go 21 minus 12.
But it starts out
Okay.
with the subtraction.
Oh no, don't act dumb right now. We're in front of a math teacher. Stop it. Sorry, my brain's going.
Hey, you're fine. I ain't gonna hit you or nothing. I mean, you're fine.
No.
Oh, my goodness.